Hey everyone, welcome to the new video face recognition using Python. But before start the video, let me introduce that Great Learning has come up with the idea of Great Learning Academy, where you will get almost 80 plus free courses, and after completing your course you can claim your certificate as well. And if you want to do these courses in your mobile application, that is also possible using Great Learning app. So let's get back to the video. And in this video, we are going to talk about the face recognition technique. But what is face recognition technique? Why do we need it? Right? So basically, this technique is used for object detection as well. In this particular face recognition, I can give you one example of that is face lock. So we all use our phone. This is very important thing in our life. So as we all know, there is an option or feature we have where actually you can lock your phone using your face. How they do that? Did you ever think how they actually recognize your face from the image? So basically, first they try to recognize your face from the image and using this technique, and from there they try to find it out it's you or someone else. Right? This is interesting, right? Yes, so we will learn how this technique works, how we actually do the face recognition using Python, and what are the library are going to use for this. In this video, what are the topics we are going to cover? Let's have a look on that. First, we are going to talk about what is Python. If you don't know Python, we will start from what is Python. Then we will look into how can you install Python in your local system. Then we will jump into the actual concepts we are going to learn, that is what is image processing. Then we will see what are the types of image processing we have, because there are a lot more types are there in image processing. Then also we will have a look at the library in Python which are used for face recognition or rather any image processing like project. The go-to library is basically OpenCV. What is OpenCV? How computer reads an image, we will see that as well. And then we will have a look at the history of OpenCV. Then we will start with the OpenCV, and also lastly we will do a project on face recognition using OpenCV. So let's get started with the video. So what is Python? Python is a popular high-level object-oriented and interpreted language. So from the name itself and the definition itself is saying this is high-level language. So whenever we need to communicate with the computer, we need to go for low-level language. But in the case of Python, it's already interpreted. That's why we can go for high-level language. And it is object-oriented as well. Right? So this is the basic introduction of Python. Now, if you need to install Python, you just need to go to their official web page, that www.python.org, and from there you can directly download Python. And also there is popular IDE for Python. Now what is IDE? IDE is nothing but integrated development environment. Right? For integrated development environment, what we need to do, we just need to install Python first. Then we need to go for installing particular that IDE. But why do we need IDE? We need IDE because IDE makes our life easy. Writing code in notebook or notepad, it's really hectic. But when you have IDE, it's basically make you feel like it's like giving you a proper environment to code. Right? So there are lots of IDE we have for Python. The most popular IDE is like Anaconda, we have Jupyter Notebook, we have Google Colab, right? We have PyCharm. These are the IDE option you have, right? So basically in this part, we are going to use Google Colab. I will show you how we will start with Google Colab. So let's start with the concept itself. So let's have a look at what is image processing. So image processing is a method to perform some important operation on an image in order to get an enhanced high quality image or to extract the most useful information from that. Yes, so basically image processing is a method which actually we perform for image. Right? So in order to get some, maybe for image processing, we use to identify an image, or we try to make a caption out of image, we do image processing. So image processing, it's one of type of a signal processing. In the processing input and in the processing itself, we can say as an input we give image, as an output there is no there is no hard and fast rule that you need to get an image. Maybe you can generate a caption over there, or maybe you can take some features from the images, right? So for as an input you have to give an image, but as an output you can expect a line of description for the image, that we know image auto captioning, right? That is known as image auto captioning. It's automatically it will give you the caption for the image, right? Or maybe you just try to take some features from the images. You can take anything using image processing. Now we will have a look at, so what actually does this image processing. Maybe there is one image that it's a dog or it's a cat, right? So your image processing will tell you, okay, this percentage is, this basically the probability, this is the percentage of being dog, this particular image, and this is the percentage of being cat, this particular image, right? So this is why we use image processing. There are lots of applications we have for image processing for today's today's world, but yeah, this is one of the most used concepts. Now we will have a look at what is face recognition. So we just try to understand what is face recognition. So face recognition is also comes under image processing, right? Otherwise, at the end of the day, you have to process an image to get that where your face is actually situated in the image. So the goal of face detection is to determine if there are any faces in the images or video. If multiple faces are present, each face is enclosed by a bounding box, and thus we know the location of the faces. We know that, we will see how we will do this face recognition using Python. And it is one type of a also, again, it's also one type of a signal processing. And again, in this process, you are going to give an image, and you will get an, you will get an bounded box with a face, right? So this is pretty much about face recognition. Now, if we talk about the types of face recognition, so basically we have two types of face recognition. One is feature-based approach, one is image-based approach, right? So what is feature-based approach? It locates a face by extracting structural features like eyes, nose, mouth, etc. Then uses them to detect a face. Typically, some sort of statistical classifier qualified when helpful to separate between facial and non-facial regions. Yes, in the face, in the image itself, it try to find it out the structural features, like if you have eye, nose, and mouth, it actually help them to understand, okay, there is a face. This is the region with the face, and this is the region without any face, right? This is how this feature-based approach works. Now, if we talk about the image-based approach, image-based methods rely on techniques from statistical analysis and machine learning to find the relevant characteristics of face and non-face images. The learned characteristics are in the form of distribution models or discriminant function that is consequently used for face detection. It's little high, you can say it's kind of a more complicated process, but yeah, this is the this is the more accurate way to find a face from an image, right? So in this case, we basically use machine learning, statistical analysis to understand where this image is actually practically situated in the image, right? So this is the two types of approach we have for face recognition. Now we will have a look at OpenCV. Right. So now you will ask me, why do we need to know OpenCV? We need to know OpenCV because it's one of the most used library for image processing, which under Python. So OpenCV is an open source library which is widely used for computer vision purpose. It helps us to develop a system which can process images and real-time video using computer vision. OpenCV focused on image processing, real-time video capturing to detect faces and objects. So this is what actually OpenCV stands for. Now you will ask me how OpenCV comes into the picture. So basically OpenCV was invented by Intel in 1999 by Gary. The first release was in the year of 2000, and OpenCV stands for Open Source Computer Vision Library. The library is used or based on optimized C and C++, and it supports Java and Python along with C++ through interfaces, right? So this is pretty much about OpenCV. So OpenCV was invented by Intel itself, you can see. So yeah, it's pretty much about the OpenCV we are going to use. Now we will see how image input works in computer. As we said, we have an eye, so we can see that, okay, this is the picture, this is cat, this is dog. But how a computer can actually detect a picture, because the computer doesn't have eye. So converts images into an array of pixels values where the dimension of array depends on the resolution of the image, right? So basically what they do, they actually convert the images into an array of pixels. So this values, pixel values, by the using those pixel values, the computer understands there is an image and this is the region where some object can be there. Right, in the image you can see this is how this images converts us into an array. We will see in the demo part itself. An array of dimension 32 cross 32 cross 3. The 3 basically refers to the RGB value, that red, green, and the RGB concepts we have. For that we have this into 3 if you have a colored picture. Right, we just saw that how a computer can see an image, and also we will see that what is OpenCV, and we also let's try to understand what is Python. So let's go to the demo and try to understand that how face recognition using Python works. So basically we came to Google Colab, and here we are going to see what is OpenCV. So a color face is a way for representing color in such a way that makes it easily reproducible. Right, so it's basically color space we use in a way to representing the colors for a way that makes them easily reproducible. Right, we know that grayscale images, so basically when we do image processing we try to use grayscale image, right, not the color image. So the grayscale images have single pixel values and color images contain 3 values for each pixels. Right, so always remember, for into 3, if you have as a shape into 3, that means your images are in colored mode. Right, if your images are in grayscale, then you will get there is a pixel value will be single value. Right, so most computer visions use cases process images in RGB format. However, application like video compression and device independent storage, these are heavily dependent on other color spaces like that hue saturations value, that's known as HSV color space, right, which is basically going to give you the percentage and mix and match of RGB values. Right, so as you understand, a RGB image consists of color intensity of different color channels, that is the intensity and the color information are mixed in RGB color space, but in HSV color space the color and the intensity information are separated from each other. This makes HSV color space more robust to lighting changes. Right, so basically this is pretty much about the HSV color, the color space, the grayscale. Right, so let's start with OpenCV. So how to install OpenCV? You just need to write pip install OpenCV Python. So your OpenCV will be installed. Now if you're just going to use Google Colab, that time you just need to you just need to write one more particular library you have to import, that from google.colab.patches import cv2 _ IamShow. So basically when we actually install OpenCV, we just need to write import cv2. Now we just need to do one thing. We need to read our image, which will do what? Which will actually change our images into an array. We will see as well. So read an image, we are going to use .imread function. So cv2.imread and content download 123.jpg. So here if you click here, it's already I have uploaded my data over here. Now if you want to change, take the path over here, just click over here and click on copy path. You will get this path. Right, so now after you copy this part, let me just cross it, put it over here. Right, so what we have done, we have actually read the image. Now if I just want to see how they are actually trying to convert the images, you can see what my image the computer reads, it's an array. Right, it's not an image first, it's an array. Now if you want to see the images what we have actually read, that is cv2 _ IamShow, and you have given the image. Yes, your image is actually read by the computer itself, but this is in the array form. right? So what we were saying, that computer doesn't have eye, that then how a computer can see an image. So yeah, this is the way that actually convert the images into an array. Now, if you want to check the shape of the image, like it's a color image or it's a grayscale image, you just need to write dot shape function. If you just execute that, you can see you will get 207, 243, 3. So this 3 is nothing but your RGB value. Now, when you are actually reading this particular image, that time if you want to read it in a grayscale, you just need to write 0 over here. For the parameter, if you write 0 over here, you will get an grayscale image. If you just write 1 over here, you will get an colored image, right? The image you are giving as an input. So in this case, if I just do that, you can see these images in the grayscale. Now, if I just do the same thing, and if I just write 1 instead of 0, I will get a colored image. Can you see? I get the color image over here. Now, if you just see this image, right? And if I just write img.shape, okay, I will get an error. Right, can you see here, when it's actually is a gray one, right? That time you will not get the 3. Basically it's 1, so basically it does not give you 1. So if you don't get 3 over here, you can see this 3 is basically for RGB value. Now this is the way we actually can read the images. Now there are, like what we are talking about, like the facial landmarks like eyebrow, eyes, jaws, nose and mouth, etc. So these landmarks are used for localizing and representing salient regions or facial parts of the person's face. Right, so this is how this OpenCV basically try to find it out a face in an image. Now if you just try to change it using cv2.cvt color, so you can use this as well, that cv2.cvt color, then you are passing the image and the image will be BGR to RGB, right? So in this case, if you just show this, you can see again you will get an gray image over here. Now we are going to do the face detection. Here we are going to use a function called detect multiscale function. Before that, let's have a look at the other thing. Suppose we are imported CV2. That's not needed. It's already imported. And okay, I have imported CV2 so many times. Okay, now what we are going to do, we are going to use a har cascade file. So what is a har cascade file? Har cascade is a machine learning object detection algorithm used to identify objects in the image or video based on the concepts of feature proposed by Paul Weiler. And the paper is basically we have there are two scientists we have. One is Paul Weiler and Michael Jones in their paper Rapid Object Detection Using Boosted Cascade of Simple Features in 2001. Right? So this is how har cascade concepts comes into the picture. It's basically a machine learning concepts for object detection. So you can see what we are going to do. We are going to, here we have this har cascade frontal face default file. This is a .xml file, and you can see we have actually read this file using cv2.cascade classifier. You can see in the variable called face cascade we have used this. Now we have read this image that download 123.jpg, and there we are actually changing it to gray. How we are changing it to gray? We have written like cv2.color bgr to gray. Right, so this is how we can change the color. Basically what happened when we do the processing, we try to use the gray color. Right, so gray color picture to get the proper places where these objects are situated in the image. Now it's you are going to use face cascade dot detect multiscale gray 1.1, 4. So let's have a look at what is a detect multiscale function. So it is used to detect the faces. It takes 3 arguments: the input image, scale factor, and minimum neighbors. So scale factor specify how much the image size is reduced with each scale, and minimum neighbors specify how many neighbors each candidate rectangle should have to retain it. Right, so you can see these are the parameters we have for detect multiscale. Now we are going to use a for loop. There is a for part in our face, x, y, w, h. right? So in this case, you can see for x, y, w, h in faces, we are going to make a rectangle. So CV to that rectangle, then we are passing the image, then x comma y, x plus w, y plus h, then 255, 0, 0 and 2. Right, so now if I just execute it, you can see there is a rectangle near your face. So it's basically successfully detected the fakes in the image itself. Now if you say, hey, is it just only one image we have in the image? So only one face we have in the image. So if we have multiple face, what will happen? So for that, we have used one more image over here, right? So now if I just try to show you what image we have used, you can see this is okay. I just need to do that. Right. So in this case, you can see the image we are going to get. We will have lots of, 6 different faces in one image, right? So now we will do the same thing over here, and we will try to check is like if we have multiple faces in one picture, it's able to find it out or not. So in this case, you can see the 6 different faces we have over here. They are particularly detected and successfully detected by OpenCV. So this is how we do the face recognition using OpenCV in Python. So I hope you liked the tutorial, and please do let us know in the comment section what else you want to learn from us. And also please let us know what you feel about this particular tutorial. Before complete the tutorial, let me introduce that Great Learning has come up with the idea of Great Learning Academy, where you will get almost 80 plus free courses, and after complete your course, you can claim your certificate as well. And if you want to do these courses in your mobile application, that is also possible using Great Learning app. Thank you so much.